All right, so yeah, it's been a couple of years now. I was sick 2 years ago, and then 1 year ago tomorrow, my little boy was born, so I had to miss QuakeCon last year. This year, you get another one of my normal hour-and-a-half, 2-hour-long stream of consciousness talks about hardware platforms and software development. And if someone will stop me when we've got about a half hour left, I will be taking questions from the audience. So first, especially after looking at like the Quake 4 demo, it's worth sitting back and just reflecting about how amazing the industry has been, the type of progress that we've seen. You know, a long time ago, a graphics pioneer once said that equipped that reality is 80 million polygons a second. And we're past that number right now on cheap console hardware. Later, that number was fudged to 80 million polygons a frame because clearly we don't have reality yet, even though we have 80 million polygons a second. But still, the fact is, that was a number that was picked to just be absurd. You know, it was a number that was so far beyond what people were thinking about in the early days that it might as well have been infinity. And here we are with cheap consoles, PC cards that cost a few $100s that can deliver performance like that, which was basically sort of beyond the imagination of the early pioneers in graphics. And not only have we reached those kind of raw performance throughput numbers, but we have better features than the early systems that people would look at. You can look at a modern system and say it is better in essentially every single respect than multi-billion-dollar image synthesis systems of not too many years ago. And unlike a lot of the kind of marketing quips that people make about when this or that chip is faster than a supercomputer, which are usually fudged numbers when you start talking about only executing in cache, ignoring bandwidth, and this or that to make something sound good. That's not really the case with the graphic capabilities that we've gotten, where not only do we have raw triangle throughput, we've got this programmability that the early graphic systems just didn't have at all. We've got better image fidelity coming out. We've got higher multiple scan-out rates, all of this stuff. And we're getting them in the next generation of consoles for just a few $100s. And the PC space is still advancing at this incredibly rapid clip where while everybody's kind of saturated with the hype, the marketing hype of Microsoft and Sony about the next generation of consoles, they are wonderful, but the truth is they're about as powerful as a really high-end PC right now, and a couple years from now, PC platforms, you're going to be able to put together a system that's several times more powerful than these consoles that are touted as the most amazing thing anybody's ever seen. But this trend of incredible graphics performance, what it's allowed us to do, and this is great following just up on the Quake 4 demo because there's a whole lot of shock and awe in everything that they show there, and that is a direct result of what we're able to do because of the technology. And it is often sort of derided as being a technology-focused company where a lot of people will get on this high horse about game design purity. But the truth is, the technology that we provide and we're able to harness from the industry is what lets us do such a memorable gaming experience. And while you can reduce a game to its sort of symbolic elements in what you're doing and what your character accomplishes, you can't divorce that from the experience that you get with the presentation. So the presentation really is critically important. And to some degree, id Software has actually been singled out by some developers as actually causing problems for the industry by raising the bar so much, and I am sympathetic to this. It's a serious topic to talk about in software development, where as the budgets get larger and larger, we're talking about tens of millions of dollars, there are people that have said explicitly they wish that, say, Doom 3 or now Quake 4 hadn't shipped because now every game is expected to look that good. Every game is expected to have that level of features because the bar has kind of been raised. And things like that happen in a lot of other areas also. It's going on with physics as well as graphics, where every game is expected to have a physics engine. And I have some sympathy for them because there are elements like, I sometimes find it unfortunate that we effectively have to make a B movie to make a computer game nowadays, where sometimes it'd be nice to be able to just concentrate on a game being a game and not worrying about having to have hours of motion capture footage and cinematic effects, but that's just kind of what games are expected to have nowadays. But the technology has provided real, absolute benefits to the game-playing public, to the people that are playing these games. Sometimes people will look through the tinted glasses of nostalgia and think back to some time where maybe gaming was less commercial, less promoted, less mainstream, less whatever, and think back to, you know, the golden age. But the truth is, the golden age is right now. Things are better in every respect for the games that you can play now than they ever have been before. It's driven home when you take something like watching the Quake 4 trailer here, and then you go back, and most people here will have very fond memories of Quake 1. You know, the great times that you had playing that and things that will be stuck in your memory. But you then go and run them side by side, and you could have fun in that game, and there would be moments of, of wonder at the newness of it, but it won't have the presence and the impact and the ability to really get in and stir up your guts that we can do with the modern state-of-the-art games. So I'm not apologetic at all for the effort that we've put into pushing the technology, what we've been able to do to allow the artists and designers to present a world that's more compelling than what we've been able to do before, and to make stronger impacts on the people playing the games. You know, that's all been really good. And the trends are still looking really strong. There's nothing on the immediate horizon that would cause us to expect that over the next several years we're not going to see another quadrupling and eventually another order of magnitude increase in what we're going to be able to do on the graphics side of things. So the console platform is going to become more important for us in the future. It's interesting now that when we look at the Xbox 360 and the PS3 and the PC platforms, we can pretty much target essentially all of them with a more or less common code base, more or less common development strategies on there. And this is, I guess, going to be the first kind of public announcement of it, but this will be the first development cycle for id Software where we're actually going to be internally developing on console platforms for a simultaneous, hopefully, release on there. In the last couple of weeks, I actually have started working on an Xbox 360 for most of the upcoming graphics development work. We'll be starting on that initially. And it's worth going into some of the reasons behind that decision on there. You know, to be clear, the PC platform will be released at least at the same time, if not earlier, than any of the consoles. But we are putting a good deal more effort towards making sure that the development process goes smoothly onto them. While Doom 3 on the Xbox is a great product, we're really happy with it. It's been very successful. It was pretty painful getting that out after the fact of Doom 3, and we intend to make some changes to make things go a little bit smoother on this process. But we've been on again, off again with consoles for a long time. I've done console development work back on the original Super Nintendo and several platforms up through today. And there's always the trade-off between flexibility on the PC and the rapid evolutionary pace that you get, and the ability to dial down and really take the best advantage of the hardware that you've got available on the consoles. And it's worth sort of taking a little retrospective through the evolution of the PCs and the console space on there. In our products, if you look back at the really early days, up through basically Doom, the original Doom, we were writing essentially register level access to most of the PC video cards. We would use special modex graphics and things like that to get a few extra features out of that. And once we got beyond that point, especially after we moved to Windows with post-Quake development, it's become a much more abstract development process where we program to graphics APIs and use the system software interfaces. And that certainly helped the ability to deploy widely and have a lot of varied hardware work reasonably well. I mean, we can certainly remember back in the original Doom days, we had a half dozen different audio drivers for Pro Audio Spectrums and Ad-Libs and all this other stuff that we've pretty much been able to leave behind. And eventually with the 3D space, there was the whole API wars issue about how you were going to talk to all of these different graphics cards, because for a while there were 20 graphics chips that were at least reasonable players. It's nice now that it's essentially come down to ATI and NVIDIA, both of whom are doing very good jobs on the 3D graphics space. But especially in this last development cycle, the last year that I've been working on some of the more advanced features, it has been troublesome dealing with the driver situation about bringing in new features, new hardware, new technologies that I want to take advantage of that have required significant work in the driver space, where there have been some significant driver stability issues as they've had to go do major revamps to bring in things like frame buffer objects and some of the pixel buffer renderings and stuff like that has given us some headaches at id, where we have one driver revision that fixes something that makes our tools work correctly, but that happens to cause the game to run slow because there's some heuristic thing going on with buffer allocations, and we've had things kind of ping pong back and forth between some of that. And I've had some real difficulty trying to nail down exact graphics performance on the PC space because we are distanced from the hardware a fair amount. The interfaces that we go through, they don't map one-to-one to calling this results in this being stuck into the hardware buffer, which is going to cause this to draw. There are a lot of things that are heuristically done by drivers now that will attempt to not necessarily do what we say, but do what they think we meant in terms of where buffers should go, how things should be allocated, how things should be freed. And it's been a little bit frustrating in the past year trying to nail down exactly how things are going to turn out, whether I can say something is my fault, the driver's fault, or the hardware's fault. So it's been pretty refreshing to actually come down and work on the Xbox 360 platform, where you've got a very, very thin API layer that lets you talk pretty directly to the hardware. You can say, this is the memory layout, this call is going to result in these tokens going into the command buffer, and so on. And the intention is that I'm probably going to be spending the next 6 months or so focusing on that as a primary development platform, where I'll be able to get the graphics technology doing exactly what I want, the performance that I want on this platform where I have minimal interface between me and the hardware, and then we'll go back and make sure that all the PC vendors have their drivers working at least as well as the console platform on there. So we do have PS3 dev kits also, and we've brought up some basic stuff on all the platforms, but a lot of people assume for various reasons that I'm anti-Microsoft because of the OpenGL versus D3D stance, but I'd actually like to speak quite a bit in praise of Microsoft in what they've done on the console platform, where the Xbox previously and now the 360 have the best development environment that I've ever seen on a console. And I've gone a long ways back through a number of different consoles and the different things that we've worked with. And Microsoft does a really, really good job because they are a software company and they understand that software development is the critically important aspect of this. And that is somewhat of a contrast to Nintendo and Sony and previously Sega, who were predominantly hardware companies, and decisions will get made based on what sounds like a good idea in hardware rather than what's necessarily the best thing for the developers that are actually going to be making the titles. Over the history of the consoles, there's been sort of this ping-pong back and forth between giving good low-level access to the hardware, letting you kind of extract the most out of it, and having good interfaces and good tools to go with it. In the real old days of side-scrolling, tile-based consoles, you got register access, and that was pretty much it. You were expected to do everything yourself, and the hardware was usually pretty quirky and designed around a specific type of game that the vendors thought you would be making on there. And it's entertaining to program in its own way there. But the first, I think, really big change that people got was when the original PlayStation 1 came out, and it had a hardware environment that they didn't actually originally let you get at the lowest level graphics code on there, but they designed fast hardware that was easy to program. One fast processor, one fast graphics accelerator, and you got to program it in a high-level language on there. And the contrast with this was the Sega Saturn at the time, which had 5 different processing units, and was generally just a huge mess. They did document all the little low-level hardware for you to work at, but it just wasn't as good of an environment to work on. So it was interesting to see with the following generation that Sony kind of flip-flopped with the PlayStation 2, where you now had low-level hardware details documented and all this, but you were back to this multi-core, not particularly clean hardware architecture. And then Microsoft came out with the Xbox, which had an extremely clean development environment, the best you've really seen on the console to date, but you didn't get the absolute nitty-gritty low-level details of the 3D system on there. And I know Microsoft actually, there's a lot of kind of bickering back and forth about, is it NVIDIA's fault or Microsoft's fault or whatever on there. But still, it was a clear advantage for developers. I mean, if you ask developers that worked on Xbox and PS2, the Xbox is just a ton nicer to develop for. So it's been interesting to see that Microsoft has had a good deal of success, but they haven't been able to overtake Sony's market dominance in there with the earlier release of the PS2. So it's going to be real interesting to see how this following generation plays out, with the Xbox 360 coming out first and being more developer friendly, at least in our opinion, and Sony coming out a little bit later with the PS3. Hardware-wise, there's again a lot of marketing hype about the consoles, and a lot of it really needs to be taken with grains of salt about exactly how powerful it is. I mean, everyone can remember back to the PS2 announcements and all the hoopla about the emotion engine and how it was going to radically change everything. And, and it didn't. It's just, its processing power was actually kind of annoying to get at on that platform. But if you look at the current platforms, in many ways, it's not quite as powerful as it sounds when you add up all the numbers and flops and things like that. If you just take code designed for an x86 that's running on a Pentium or an Athlon or something, and you run it on either of the PowerPCs for these new consoles, it'll run at about half the speed of a modern state-of-the-art system. And that's because they're in-order processors. They're not out-of-order execution or speculative, any of the things that go on in modern high-end PC processors. And while the gigahertz look really good on there, you have to take it with this kind of divide by two effect going on there. Now, to compensate for that, what they've both chosen is a multiprocessing approach. And this is also clearly happening in the PC space, where multi-core CPUs are the coming thing. And everyone is essentially being forced to do this because they're running out of things that they can do to make single processor, single thread systems go much faster. And we do still have all these incredible market forces pushing us towards follow Moore's law, faster and faster. Everyone needs to buy better systems all the time. But they're sort of running out of things to do to just make single processors much faster. We're still getting more and more transistors, which is really what Moore's law was actually all about. It was about transistor density that you get, and everyone's sort of misinterpreted that over the years to think it's going to be faster and faster, but it's really more and more. And historically that has translated into faster and faster, but it's getting more difficult to make that direct correlation over there. So what everybody's having to do is exploit parallelism. And so far, the huge standout poster child for parallelism has been graphics accelerators. It's the most successful form of parallelism that computer science has ever seen. We're able to actually use the graphics accelerators, get all their transistors firing, and get good performance that actually generates a benefit to people using the products at the end of it. Multiprocessing with the CPUs is much more challenging for that, and it's one of those things where it's been a hot research topic for decades. You've had lots of academic work going on about how you parallelize programs, and there's always the talk about how somebody's going to somehow invent a parallelizing compiler that's going to just allow you to take these multi-core processors, compile your code, and make it faster, and it just doesn't happen. There are certain types of applications that wind up working really well for that. Things that are either, the technical term is actually embarrassingly parallel, where you've got an application which really takes no work to split up. Things like ray tracing or some of the big mathematics libraries that are used for some vector processing things. But The analogy that I tell hardware designers is that game code is not like this. Game code is like GCC, a C compiler with floats. And it's nasty code with loops and branches and pointers all over the place, and these things that are not good for performance on, in any case, let alone these kind of parallel environments. So the returns on multi-core are going to be initially disappointing for developers, or for what people get out of it. And there are decisions that the hardware makers can choose on here that can make it easier or harder. And this is a useful comparison between the Xbox 360 and what we'll have on the PC spaces and what we've got on the PS3. So the Xbox 360 has an architecture where you've essentially got 3 processors, and they're all running from the same memory pool, and they're synchronized, and you've got cache coherent, and you can just kind of spawn off another thread in your program and have it go do some work. Now, even that's kind of the best case, and it's still really difficult to actually get this to turn into faster performance or even getting more stuff done in a game title. The obvious architecture that you wind up doing is you try and split off the renderer into another thread, which was Quake 3 supported dual processor acceleration like this off and on throughout the various versions. And it's actually a pretty good case in point there, where when we released it, certainly on my test system, you could run and get maybe a 40% speed up in some cases running in dual processor mode. But through no changing of the code on our part, just in differences as video card drivers revved and systems changed and people moved to different OS revs, that dual processor acceleration came and went multiple times. And at one point, we went to go back and try and get it to work, and we could only make it work on one system. And we had no idea what was even the difference between these two systems. It worked on one, not on the other. And a lot of that is operating system and driver-related issues, which will be better on the console. But it does still highlight the point that parallel programming, when you do it like this, is more difficult. And anything that makes the game development process more difficult is not a terribly good thing. So the decision that has to be made there is the performance benefit that you get out of this worth the extra development time? And there's sort of an inclination to believe that, and there's some truth to it, and Sony sort of takes this position where, okay, it's going to be difficult, maybe it's going to suck to do this, but the really good game developers, they'll just suck it up and make it work. And there's some truth to that. There will be the developers that go ahead and have a miserable time and do get good performance out of some of these multi-core approaches, and Cell is worse than others in some respects here. But I do somewhat question whether we might have been better off in this generation having an out-of-order main processor rather than splitting it all up into these multiprocessor systems on here. It's probably a good thing for us to be getting with the program now. The first generation of titles coming out for both platforms will not be anywhere close to taking full advantage of all of this extra capability. But maybe by the time the next generation of consoles roll around, the developers will be a little bit more comfortable with all of this and be able to get more benefit out of it. But it's not a problem that I actually think is going to have a solution. I think it's going to stay hard. I don't think there's going to be a silver bullet for parallel programming. There have been a lot of very smart people and researchers and so on that have been working this problem for 20 years, and it doesn't really look any more promising than it was before. So that was one thing that I was pretty surprised when I was talking to some of the IBM developers of the Cell processor on there. I think that they made, to some degree, a misstep in their analysis of what the performance would actually be good for, where one of them explicitly said, basically, now that graphics is essentially done, won't we have to be using this for physics and AI? And that's what, those are the two kind of poster childs that are always brought up for how we're going to use more CPU power, physics and AI. But the contention that graphics is essentially done, I really think is way off base. I mean, first of all, you can just look at it from the standpoint of, are we delivering everything that a graphics designer could possibly want to put into a game with as high of quality as they could possibly want? And the answer is no. We'd like to be able to do Lord of the Rings quality rendering in real time. We've got orders of magnitude more performance than we can actually suck up in doing all of this. What I'm finding personally in my development now is that the interfaces that we've got to the hardware with the level of programmability that we've got, you can do really pretty close to whatever you want as a graphics programmer on there. But what you find more so now than before is that you get a clever idea for a graphics algorithm that's going to make something look really awesome and is going to provide this cool new feature for a game. You could go ahead and code it up and make it work, make it run on the graphics hardware. But all too often I'm finding that, well, this works great, but it's half the speed that it needs to be, or a quarter of the speed. Or then I start thinking about something, well, this would be really great, but that's going to be 1/10 the speed of what we'd really like to have there. So I'm looking forward to another order of magnitude or two in graphics performance, because I'm absolutely confident that we can use it. We can suck that performance up and actually do something that's going to deliver a better experience for people there, which if you say, okay, here's 8 cores, or here later it's going to be here's 64 cores or whatever, do some physics with this that's going to make a game better. And that's real, or even worse, do some AI with this that's going to make a game better. The problem with both of those, is that both fields, AI and physics, have been much more bleeding edge than graphics has been. And to some degree that's exciting, where people in the game industry are doing very much cutting edge work in many cases. It is the industrial application kind of for a lot of that research that goes on. But it's been tough to actually sit down and take some of that and say, all right, let's turn this into a real benefit for the game. Let's go ahead and how do we use however many gigaflops of processing performance to try and do some clever AI that winds up using it fruitfully. And especially in AI, it's one of those cases where most of the stuff that happens in especially single-player games is much more sort of a director's view of things. It's not a matter of getting your enemies to think for themselves. It's a matter of getting them to do what the director wants to put the player in the situation that you're envisioning in the game. Multiplayer-focused games do have much more case for it. You want to have better bot intelligence that's more of a classic AI problem on there. But the bulk of the games still being single player on there, it's not at all clear how you use incredible amounts of processing power to make a character do something that's going to make the gameplay experience better. I mean, I keep coming back to examples from the really early days of the original Doom, where we would have characters that are doing this incredibly crude logic that fits in like a page of C code or something. And characters are just kind of bobbing around doing stuff. And you get people that are playing the game that are believing that they have devious plans and they're sneaking up on you and they're lying in wait. And this is all just, people taking these minor cues and kind of incorporating them in their head into this vision of what they think is happening in the game. And the sad thing is, you could write incredibly complex code that does have monsters sneaking up on you, hiding behind corners, and it's not at all clear that that makes the gameplay any better than some of these sort of happenstance things that would happen as sort of emergent behavior of very trivial, simple things.